All right, we are going to take a look at an example of dividing rational expressions. I'm only doing this just dividing because dividing is very similar to multiplying. So there's just one little twist, and so this example is going to serve as an example for multiplying and dividing rational expressions. The other thing is, I wanted to throw in some stuff that we had in other previous videos. I want to remind you, you'll still need to know how to do x factor, and you might need to know how to do difference of squares. And you're going to need to know how to factor out a -1 if necessary. In addition to all that, I'm going to remind you of what it means to divide by a fraction. So, if we have something like 2/3 divided by 4/5, the way that we're supposed to deal with that is we're supposed to take the second fraction and flip it, and then change that divided by to multiply. And that supposedly gets us the exact same result as if we did 2/3 divided by 4/5. I'll leave it up to you to try it in a calculator. Go ahead and try doing 2/3 divided by 4/5 and see what you get. And then we're going to do this. We'll go ahead and we'll multiply. Now, we're actually allowed to do some canceling here. I'm going to go ahead and cancel this 2 and this 4. And that's something that's new. I haven't shown you this before. Even though there's a multiply sign in between, I'm still allowed to cancel the 2 and the 4. I get a 1 up here and I get a 2 down here. Now some of you might be wondering, well, how is that? What allows me to cancel across that multiply sign? And here, I'll go ahead and back up and I'll show you. The deal is this, is that when we have this multiply sign, it really just means multiply the tops and multiply the bottoms. And there's this handy-dandy little property of real numbers that's known as the commutative property that says that if I'm multiplying two numbers or any amount of numbers, I can switch them around and I'll still get the same result. So I'm going to go ahead and change that 2/5, or I'll leave the 2 times 5 and I'll change the 3 times 4 to 4 times 3. And now what you can see is I have one fraction and the 2 and the 4 are directly above one another, and so therefore I can go ahead and cancel. For those of you who practice multiplying and dividing fractions and get good at it, you'll come to the realization that you don't need to do all these steps. You can just go and cancel this 2 and cancel this 4. Now, does it work if there's an equal sign in between? No. So maybe we better make a note of that. Let's go ahead and maybe we'll just say if we have 2/3 and it equals 5/4, are we allowed to cancel these guys? No, that's not a rule. Okay, forget about all that. And what about if it's a plus sign? What if we're doing 2/3 plus 5/4? Can we then go ahead and cancel this and this? And the answer is no, we cannot. So forget about that as well. And again, you might be wondering, well, what's the reason why? And I guess the bottom line reason why you can't do these things is because if you try to do the canceling when you have the equal sign in between, then you change the equation. If you try to do the canceling when you have the plus sign in between, then you change the value of these numbers. If we do the canceling when we have the 2/3 times the 5/4, we do not change the value of the multiplication problem. In other words, 2/3 times 5/4, if you do it in a calculator, is exactly the same as 1/3 times 5/2. You get the same value. That's why the canceling works with the multiply, and that's why it doesn't work with the equal or the plus sign. All right, let's continue. Sorry about that. Okay, so anyways, we're back to, let's go ahead and finish this off. So ultimately, if we multiply by a fraction, we will take the second fraction and we'll flip it, and then we'll change divide to multiply. And by doing that, we can get a result that's correct. And in this particular case, it would have been 5/6. And again, if you do 2/3 divided by 4/5 on your calculator, if you put the parentheses in and do it properly, you should get the same result as if you do 5 divided by 6 in your calculator. Okay, Sorry for taking so long to explain that. Let's get back to this guy up here. Now we want to use this principle to divide a much bigger, more complicated set of fractions. So first thing we'll do is we will rewrite this guy. I'm going to go ahead and do some factoring while I'm rewriting. 4k cubed, I'm just going to leave exactly as it is. This 9 minus k squared, I'm going to go ahead and factor out a negative 1 and make it into k squared minus 9. Hopefully you guys can check for yourself that negative 1 times k squared minus 9 is exactly the same as 9 minus k squared. All I did is factor out a negative 1. And then we'll leave the k plus 5. And then in the bottom, we'll go ahead and do x factor. And I believe when we do, we get something like k, it looks like minus 9 and k plus 2. And then finally, we'll change that divided by to times, and we'll flip over the second fraction. So we get k plus 2 all over 28k times k plus 3. There we go. And then we can go ahead and start canceling like mad banshees. We'll go ahead and cancel, let's put in implied parentheses around this guy, and we'll cancel this k plus 2 and this k plus 2. And then, this guy needs to be factored, this k squared minus 9. So I'm going to go ahead and rewrite this. Let's go ahead and rewrite this whole thing. So let's see here, we've got 4k cubed, and I took that negative 1 out. We'll leave that negative 1 out, and now I'm going to factor this as a difference of squares. This is k minus 3 times k plus 3, and it's still times k plus 5, and it's all over k minus 9, and then times 1 over 28k times k plus 3. And let's give myself a little bit of room here. We'll spread out. Let's go ahead and take her over there. You might want to cancel this k minus 3 and k minus 9, but you cannot, so just leave that alone. I'm going to move with the negative 1 out in front because I can. I can just change the order of things that I'm multiplying. So I'm just going to say it's negative times 4k cubed instead of 4k cubed times negative 1. I'm going to go ahead and cancel this k plus 3 and this k plus 3. There was a means to my madness there. And now that I've done that, I can go ahead and do k minus 3 times k plus 5. And that will still be all over. I'm going to take that 28k and put it out in front. And that'll be times k minus 9. And again, there should have been implied parentheses here and implied parentheses here. And that's why the 28k is just times k minus 9, and we can put it right out in front. Now, since I have k cubed on top and k on the bottom, I can cancel. When I do, this gets me k squared on top and simply 1 down below. And 4 and 28 cancel. That gets me 1 up here and 7 down here. And so we'll go ahead and rewrite all that. Let's go ahead and try just like this. It'll be negative k squared and then times k minus 3 times k plus 5, and that'll all be over 7 times k minus 9. And I'm going to box that. That's my final answer. The only thing is I will ask you this. If this was a function, if it was f of k equaled all this stuff, I would ask you, for what values of k is this guy undefined? Remember, that's a recurring theme in all this, so I'm going to keep asking that question. You go ahead and pause the video and see if you can figure it out. In a second, I'm going to tell you. Okay, hopefully you pause the video. And here's what my thought is that k, the domain for this function, the values of k can be all real numbers, except k cannot be positive 9. And the reason why is because we have k minus 9 there, so therefore k cannot be equal to 9. All right, that's a good example of dividing rational expressions with all the frills, all the fixins. Hope you enjoyed it.